Welcome, dear listeners. In this video, we'll take a look at Uplift modeling and discuss what application it can be useful for. So let's say that our company has developed a new product and we would like to advertise it, for example, by calling customers. However, usually we cannot call all our customers because the capabilities of the call center are limited. Here comes an idea. Let's try to predict which customers should be called so that they agree to the purchase, and which ones should not, because they will not buy anything even after the call. The easiest option is a so-called lookalike model. It takes the features of the client and predicts the probability that our client takes the target action. For example, buying a new product. As a training sample, we will use historical data, which customers previously agreed to purchase and which did not. Thus, the lookalike model will search for new customers similar to those who performed the target action. Another option is to build a response model. In contrast to the lookalike model, it predicts the probability of a target action after communication with the client. In this context, the act of communication is often called a treatment. Hence, we need a training sample obtained after treatment of customers. We want our sample to have both positive and negative observations. That is, that one customer bought the product after treatment and the other one did not. But the most advanced option is Uplift modeling. Uplift is the difference between the effect after treatment and the effect without treatment. The Uplift value shows how much our interaction with the client influenced his decision to take the target action. Let's look at the slide. There are customers who were ready to buy our product just like that, but after a call, apparently out of harm, they lose the desire to do so. Such clients do not need to be disturbed in any case. The other two types of customers are loyal and lost. Our call will not affect their decision to purchase the product. And the last type of customers is persuadable. Our call will induce them to buy the product. Such customers should be called first, and Uplift modeling allows us to distinguish them. As we have already discussed, Uplift modeling may be useful for offering a new product or service, but it can also be used to prevent customer churn and complaints. The main problem of Uplift modeling is that we can't get the Uplift value for a single client. Indeed, we cannot both interact and not interact with the client at the same time. Therefore, we can evaluate the effect of treatment only on a group of clients, and it should include both those with and without the treatment. Before training the model, it is necessary to conduct a pilot study. We need to divide the sample of clients into two groups, target and control, and treat only the target group. It is important that the grouping is random and both groups are representative. Based on the results of the pilot study, we will train the model, so we will need to wait until the clients take or do not take the target action. But first, a few caveats about what not to do when conducting a pilot study. We should not send to the control group those clients who are obviously less likely to complete the target action. Similarly, it would be wrong to send to the target group those customers who are obviously more likely to take the target action. We want the presence or absence treatment to be the only thing that distinguishes the two groups. For the same reason, it is a bad idea to split clients into groups by some feature, for example by gender or by age, since in this case, the groups will have a different distribution of features. There are several approaches to Uplift modeling, and today we will discuss two. The first is called meta-learners. It involves building Uplift models on top of binary classifiers. These include, for example, T-learner and X-learner. The second approach is to model Uplift directly. In this case, a special type of decision trees is used. We will also talk about metrics for assessing the quality of the Uplift prediction. The T-learner model is the simplest one you can think of. At the first step, we train two independent models that predict the target, each in its own group, in the control and in the target. As a base model, we can use everything, for example, table or AutoML preset from LightAutoML. The uplift value for the test sample is predicted as the difference between the outputs of the two base models. The X-learner approach is more complex, but often shows better quality. The first step is exactly the same as T-learners. We train two independent models, each in its own group. We then cross-estimate the uplift proxy by subtracting the control model predictions for the target group from the target variable and vice versa for the control group. Next, we build two new independent models, each predicting the value of the uplift proxy for its own group. The final prediction for the test set is calculated as a weighted average of two independent models. As for the weights G, another model is often used. This one predicts whether an object belongs to a target or to a control group. It can compensate for the unequal distribution of features in the two groups. Another option is to maximize uplift directly, and decision trees are great for this purpose. Turns out, it is possible to modify the tree construction procedure that it maximizes the uplift. Maximizing uplift is equivalent to having the target variable distributed differently in the target and control groups. Therefore, the split at the tree node is chosen to maximize the distance between the distribution of the target variable in the target group and the distribution of the target variable in the control group. The following criterions can be used as a distance. They are presented on the slide: KL divergence, Euclidean distance, or chi-squared criterion. If we know how to build uplift trees, then we can combine them into a random forest and end up with a fairly strong model. Now, let's talk about the quality metrics for uplift modeling. Let's say we know that our call center can call k% of all customers. Then it is reasonable to use the uplift at k metric. To calculate it, we sort all clients by the value of the predicted uplift and select the top k% of clients. Among them, we consider the mean value of the target variable for target and control groups and subtract one from the other. The greater the value of uplift at k, the greater the effect of treatment with the client, and the better our model predicts. If we don't know the exact threshold of clients k, then we can do similarly to row-calc in binary classification and use the integral metrics such as the area under the curve. One option is to build an uplift curve. First, as for uplift at k, we need to sort the clients by the value of the predicted uplift. On the horizontal axis, we plot the considered proportion of customers t. On the vertical axis, there will be the value of cumulative gain. This is the uplift on the first t clients of the sample multiplied by t. We build a cumulative gain versus t curve and calculate the area under it. Accordingly, the larger the area under the curve, the better our model predicts. The curve for a baseline that randomly shuffles customers will look like a sloping straight line. We can build other curves similar to the uplift curve. Basically, they will differ only in the normalization. For example, we will get the Kinney curve if we subtract the proportion of control objects in the first t% of the sample from the same proportion of the target objects. If we multiply uplift not by the total share of clients, but by the share of clients from the target group, we get the adjusted Kinney curve. These metrics rank the models more or less equally, so the choice of metric is left to the taste of the data scientist. Let's briefly summarize the video. The uplift value is the expected difference in the values of the target variable between the presence and the absence of treatment. To construct models to predict uplift, it is necessary to divide the sample into two groups, target and control, and conduct a pilot study. It is possible to model uplift both with meta-learners based on binary classifiers and directly using uplift trees. The area under the curve, uplift or Kinney, is often used as a quality metric.